A lot of times we have questions that demand precise answers. On one hand, large language models provide answers cheaply and in mass quantities, particularly when accessed programmatically through API. On the other hand, LLM answers tend to be imprecise. Take the case of multiplying numbers. LLMs cannot do it accurately. This example is from Grok 3, which is a high-performing LLM but nonetheless not up to this task. The correct answer is shown on the lower right using Mathematica software. My favorite approach for getting precise results from text analysis is to break the LLM's tasks into a sequence of discrete choice problems, especially questions that have true or false answers. The discrete choice approach requires the sequencing of questions to depend on the previous answers in each case. I think of the questions in a tree structure and use the Wolfram Language tree processing functions. Here is an example where I looked at passages from each of thousands of federal regulations. I begin by introducing the passage, the raw data, if you will. Then the question and answer tree is followed. It begins at the root, which is shown at the top in my illustration. If the root question has a false answer, the questioning stops for the regulation and begins again for another regulation. If the root question has a true answer, then a second question is asked, and so on. Although not shown in the diagram, each prompt also includes formatting instructions for the answer. The Wolfram language makes it easy to work with tree data. You just type out your questions and answers, connecting with arrows as appropriate. This short chunk of code tells the Wolfram language to understand my edges as a tree in the mathematical sense. This second chunk initiates recursion until no more applicable branches remain. It is recursive because the chatstep function takes a tree as an argument and returns a subtree as a result. Here is the chatstep function. It receives a tree with a question node at its root. It sets up the LLM prompt by looking at the local properties of the tree node it was given. Especially, it looks at the possible answers. It receives the LLM response and then prunes the tree according to what was received. Chatstep is a completely generic function that does not depend on the particular Regulatory Flexibility Act questions I was asking. It works on any tree where nodes alternate between question nodes and answer nodes. That's all you need to have your LLM precisely analyze text.